Now let's look at a minimization problem. So this is from your textbook. Have a holiday meal turkey ranch problem, and they buy two different brands of turkey feed and blending them to provide a good low cost diet for its turkeys. Now, blending, like a product mix problem, blending problem is a classic problem used in LP in different flavors. So this is a very simple, straightforward example of that. So we can have much more complex models of blending. So here we are blending two different feeds into the feed that's given to the turkeys, right? Each pound of brand one, so those two brands of feed that we buy, so each pound of the first brand, okay, contains 5 ounces of ingredient A and 4 ounces of ingredient B, okay, and zero point 0.5 ounces of ingredient C. So there are three different ingredients that we need to worry about. Okay. Then brand 2 contains 10 of A, 3 of B, and it contains no ingredient C at all. Okay. Brand 1's cost is 2 cents per pound. Brand 2 costs 3 cents a pound. Okay. The owner of the ranch would like to use LP. Now the thing is, these ingredient A, B, and C have some requirements. We need to make sure that our feed meets those minimum requirements for a good diet. Okay, so a good diet is defined. Okay, so a good diet is defined by, okay, A must have at least 90 ounces in the feed. Okay, at least 48 ounces of B must be present, and at least 1.5 ounces of C must be present when we mix the two brands. That must be so. And then the cost per pound is 2 and 3 cents. So what is this problem about? So the problem is about how many pounds of brand A, brand 1, and how many pounds of brand 2 should we mix, okay, to have our feed for the turkeys, right? How many pounds should you use to mix such that the cost is minimum and these requirements are met? Okay, we must have at least, these are minimum monthly requirements, 90, 48, and 1.5. So let's go ahead and model this in Excel. So first we define, okay, brand 1 and brand 2, or the two brand 1 feed and brand 2 feed. And let's use the composition is ounces of ingredients. So we're going to use the compositions later. So here first thing to do is to enter the input values, right? So we have two brands of feed that we buy, and these are the ingredients that we are interested in. Okay, so here are the values. Okay, 5 and 10, minimum requirement is 90 for A. 4 and 3 for B, minimum requirement is 48. C, 0.5 in brand 1 and nothing in brand 2, minimum requirement is 1.5. 2 cents and 3 cents are the cost. So let's go ahead and color code. Okay, let's also format this a little bit better. Okay, like that. Okay, so the decision variable or changing cells is how many pounds of each feed we must use to prepare our final feed. So that will be our changing cell. So here are the three ingredients, and the minimum requirements are here. Okay. Now how much of A, B, and C will be present in our final feed, the mixed blended feed. So that would be, these are the pounds of brand 1 and brand 2 we will be using, and these are the ounces per pound in the feed. So if you do sum product of these are the ounces per pound of A, this is the pounds of brand A, brand 1 and 2 will be using, and make sure that that is absolute reference so we can copy this formula for B and C there. Okay. Now these are the amounts that will be present in our blended feed. These are the minimum requirements. So which means the type of constraint is, okay, let's center that, greater than or equal to. Okay. And the cost is again sum product of these are the costs per pound, and these are the corresponding pounds that we will be buying. So that's our cost, which needs to be minimized, and let's color code this. Okay. So now we are ready. Solver, that's our cost. So minimize, changing cells of these two. All right. Now add that set, okay, greater than or equal to that set. Okay, so that's all the constraints. So we can click OK and make sure that this is checked for non-negativity, and the solving method is simplex LP. And automatic scaling is not a problem here, and we don't have to worry about integer optimality at this point. So we don't make any changes there, and that's it. So we solve. So we have found a solution. Okay, 31.2 cents is the minimum cost, 8.4 pounds of brand 1, 4.8 pounds of brand 2 is what we need. Okay, let's again check sensitivity. Click OK. So we have the sensitivity report here.